This is DBI's Brother Panther. I've got a database here I've been monitoring. I'm going to do a response time analysis for this database, and what I see here is for the last 8 hours, not much going on. I actually want to look at the entire week, so I'm going to look at the performance of this database for the week, and I've got a 1/4 second response time. 85% of that time is inside the database, and the database is a little bit more I/O bound than CPU bound. I'm going to click on that I/O pie slice, and Brother Panther just did the analysis to find the statements that are causing that database to be I/O bound. So right there, I've got about 2/3 of all the I/O in the database tied up in these 4 statements. I can pass those as a workload to the design advisor and apply DBI's advanced index benefit analysis methodology. So here's an I/O bound database, 2/3 of all the I/O in 4 statements. We're waiting for the answer here. Doody-doody-doody-doo. Oh, outstanding. And we can see we're going to get from 374,000 time rounds down to 116 for a 99% improvement. Here's the indexes that we have the opportunity to create, and we can see the benefit of each of these indexes. If we add this first index, we'll get 49% of that savings. If we add this second index, we get 46% of that savings. And if we add this third index, well, that's not a very big contributor to all that savings. So I take these first 2, that's the bulk of my savings, click on Create. There they are in my editor. I'm ready to go. And just like that, in about a minute, I just took 2/3 of the I/O out of an I/O bound database. Isn't that easy? Yes, it is.
Yes, thank you. So, myself, Santhosh. Today I'll be giving a presentation on DB2 LUW compression in 10.1 and 10.5. So, it's basically I'm explaining my experience, what we had in the past. So, I'll be just giving some background on compression and compression types and adaptive, mainly discussing on adaptive compression. So as you're aware that when it comes to compression in DB2, we have value compression and deep compression. So value is something that will come by default, so no need to pay anything. But the disadvantage of this is it will save very negligible amount of space. And there are 2 variations: standard row format and alternative row format. So by default, it will be standard row format, and if you want to change, you need to go for a alternative row format, but it is not preferable. So because of very negligible space saving, and the topic which is of most interest is deep compression, and it is the license. You need to have a storage optimization feature license in order to accomplish this, and this is available with the Enterprise Server Edition. And the algorithm which is used in this case is Lentil compression algorithm. And it started in the version 9, and after that there are so many improvements. And it actually saves a space of 40 to 85%. And there are 2 variations of it. There are classic row compression and adaptive row compression. I'll be explaining mostly on adaptive compression. So why not the static was there from 9, and in 10.1 there is an introduction of adaptive compression. So in the case of static, you need to have so the compression will create a static table level dictionary, and the main disadvantage of this is it requires a rearc offline in order to refresh the data, and it saves around 40 to 75% of space. But when it comes to adaptive row compression, which is a new row compression methodology in 10.1, so it will use the same principle of classic row compression, and in addition to that, it will use the dynamic page level dictionary. So that's a huge advantage. I'll explain in detail that. And overall, it will save 75 to 85% of space, and The thing is, one big advantage is it will update the dictionaries automatically. And in 10.5, we have additional features for this. It will do the in-place rearc. So no need to do any offline rearc for the adaptive compression. So, but in 10.1, you will not able to perform the in-place rearc operation. And this is how you can enable the adaptive compression. From 10.1, adaptive compression is the default option. So if you create a table with the compress S option, by default adaptive compression will be enabled. So if the table already exists, you can perform this by alter table command followed by a offline rearc. So this is what we did it in our migration part. So we did from 9.7 to 10.5. So we followed the create table, then alter the table, then we loaded the data and rearc the table. So that we experienced a good space saving. And in 10.1, we have an additional new member to the syscat.tables, that is row com mode. So its values are S, A, blank. It's very clear. S for classic and A for adaptive, and if it is not enabled, it will be blank. And I'll be explaining how it actually works. So assume that a table has 3 rows, and all these rows, 3 rows are storing in a single page. So when it comes to the first section, explains the classic row compression feature. Assume like Santhosh Somashekar, the name exists twice, and Bangalore exists twice, and MG row exists twice. Assume the classic algorithm will consider Somashekar, Bangalore, MG row as a repetitive pattern, and it will create the table level dictionary in the hidden rows of the table. So, and the next table shows the compressed table. So that's how the pointers will be mapped to the table level dictionary. And this is the second table explains the classic level compression. When it comes to the third table, that's what happens in the adaptive compression. So in addition to that, it will check for a repetitive patterns at the page level. And if any repetitive patterns, you can see like 212 in bracket 3, so that exists twice. So it will create a page level dictionary and it will map to the table. So it's again another level of compression. Advantage of this is page level dictionary is automatic. So you no need to perform any rearc, it will be updated automatically. And what are the best candidates for adaptive compression? What we have experienced is lost tables, access to table scans and read-only tables, and read of 70 or more, and very less write and less updates. And one more thing is tables with inline locks. If there are large locks, then it is not preferable to prefer the adaptive compression. So it's a better option for an inline lock. And you can estimate the compression of the data. So there's a new introduction to admin get tab compress info, new version of it. So which has only tab schema and tab name. So if you execute this, it will give the ratios specifically for what is the estimate that you get for a static and what is the estimate that you get for adaptive compression. So based on that, you can decide and prefer the option. And other option is inspect. So it will give the page level details of what is the compression estimate that you do. And best practices that you can achieve is you can follow with this. Always you can use rearc with reset dictionary along with namespace. So what it will do instead of rearc, there are 2 options. Keep a dictionary. So keep dictionary will not update to the existing values. If you use a reset dictionary, it will create a dictionary newly so that all the patterns will be updated in the table level dictionary table. And large table spaces are preferred over regular ones. So since the compressed rows are of minimum size, it will be less than minimum size. It will always go for a page size of 32 KI table spaces. And it's always, and the other option is load. By default, it will use keep dictionary option. So it's always good practice to read the dictionary, and you can regularly reclaim the free space using lower, higher watermark and reduce max. And this is what we observed. So this is our experience actually. From 3.2 terabytes after adaptive compression, it came to 550 GB. And in another case, it was in a static was around 1 TB and it came to around 700, which we observed around 17% of space savage. And advantages, it's very clear, it's storage saving and very good compression ratios, and it will improve the query performance because it will improve the buffer pool hit ratio. In turn, it will improve the query performance. And only disadvantage is it will take a more CPU cycle and memory consumption. Since the dictionaries are stored in a DB heap, it will consume a little amount of memory. And that's it from my part. Thank you very much.
All right, Santhosh. Well, you got ducked. You ran over a little bit, but it was a pretty informative presentation. So thank you for
sorry for this.
Thank you for sharing. Let's try Iqbal. You go first. Your thoughts.